Hi, my name is Tom Hollingsworth, and I'm an organizer for the Tech Field Day event series. And we're here at Tech Field Day Extra at Interop Las Vegas 2015. We've got a great group of networking professionals around the table who have taken time out of their busy presentation schedules to have a roundtable discussion about some of the exciting hot topics in networking today. And one of the ones that we're starting to see a little bit more about on the Interop show floor is actually the transition from IPv4 to IPv6. Some interesting developments as of late. And, you know, of course, there's some good information. We have some experts around the table that would love to talk about it. I'm going to step out of the way and let our delegates introduce themselves, and then we'll get started with the discussion. Justin, why don't we go ahead with you?
I'm Justin Paul at RecklessUp on Twitter, and I blog at jpaul.me.
I'm Ed Horley. I'm with Grouper Technologies. I blog at howfunky.com, and I'm at ehorley on Twitter.
Ed Wheaton. You can find me on Twitter at AvalonHawk.
I'm Stephen Foskett. I blog at blog.foskets.net, and I'm sfoskett on the Twitters.
And I'm Greg Farrow. I blog at ethereummind.com and on the Twitter is at ethereummind.
Ivan Pepelniak, ipspace.net and at iOSKins.
Ethan Banks at ECBanks on Twitter, ethancbanks.com, and packetpushers.net.
I'm Terry Slattery at NetPressman, and I blog at netpressman.com and at nojitter.com.
I'm Gideon Tam, Data Center CCIE 46006. You can find me on Twitter at mwebmahler.
Keith Parsons, Wireless LAN Professionals, and I blog at wlanpros.com.
Done. Well, to kick things off, since I'm actually sort of the IPv6 guy around the table, I wanted to talk about the other side of the equation, which is IPv4. And I noticed a couple interesting things walking the floor at Interop was that there's actually a company that I know of that's the IPv4 market group that's actually in the transfer space for IPv4. And there's another one, Rent IPv4, that's actually out there to actually rent IPv4 addresses. And I thought it was sort of interesting where the market was going and why it was going this direction. I just attended the ARIN meeting, and we're for at least North America, or sorry, US, Canada, and the Caribbean islands, we're 0.23 of a /8 left with no depletion strategy after that, so it just runs out, it runs out. So it's sort of interesting where everyone's thoughts were and whether the enterprise service provider, who was actually sort of driving down the number and whether that was going to impact anyone in the room or not.
You know, maybe it would have helped if they were rented from the start or leased from the start, you know. If you've got a limited resource, I guess, you know, from a economic standpoint, you know, you assign a price to it. Maybe they should have, forget this IPv6 stuff and have a IPv4 marketplace where people can bid and buy and sell IPv4 addresses.
So there is an aftermarket. There's actually a transfer market available today that allows for bidding prices for v4, and I think that's part of the solution, but I think it's interesting that there's a lot of legacy addressing that's out there that isn't actually run and maintained by ARIN, and so they can't control those blocks. So it's a pretty constrained resource at this day.
You know, those legacy addresses won't save us. Someone actually calculated what they would buy time-wise and the current growth. It would be like another year. And after that, you do what?
Well, what is, I mean, I've had interesting discussions with some larger companies, right? I mean, Comcast got a /9 allocation right before, you know, the major depletion happened, and IANA gave up, ran out and exhausted their pool. But I wonder what other people are seeing. I mean, I've had conversations with Greg, and he says, I don't see enterprises really being concerned. The UK is very far behind in that.
Europe doesn't care. No, like the enterprises I'm talking.
The UK may not care. Okay.
Well, you know, I'm sure the service providers care, right? But in terms of the enterprise market, they've all got /16s or /24s or /20s. Your average enterprise has got 1,000 IP addresses and uses 50. You know, by the time you do some email, you do some VPN, you do a couple of web servers maybe, and
some external peering or whatever you need to do for VPNs or something.
Yeah. I've still got 1,000 addresses, you know, or 500 addresses. I don't care. I've got no, and quite frankly, if I look at networking and I'm looking at SDN and I've got WAN problems and I need to move to application firewalls and I've got these changes coming up to shift from 1 gig to 10 gig and storage over the network is, you know, the storage people want to talk about iSCSI and you're thinking how to do it. You know, quite honestly, IPv6 is like about -10 on the radar. It's not that IPv6 isn't important, it's just not as important as everything else.
It's been on the radar for over a decade, maybe 15 years, and we've heard the same story. Your discussion, you talk about, we're going to run out. I remember sitting talking to people who were with the groups at the same time 15 years ago and said the exact same thing.
No, that was before NET. That bought us time. Now you can't do anything anymore. We ran out of all options. That's the problem this time. By the way, how big is T-Mobile in US?
Fourth?
Fourth. Yeah, Verizon, so the interesting numbers for us, I think the interesting numbers are service provider and mobile market. The mobile market in the United States for Verizon's at 64% native v6 end-to-end.
And isn't Sprint much higher?
Well, Sprint's on the map too, but I mean the reality is between Verizon, AT&T, and T-Mobile, all three of those are above 50% native v6 traffic end-to-end.
And the trick with the mobile market is that the way things are designed in the mobile world, if you're dual stack, it usually costs you 2 connections. Unless you have the latest release of the code that can actually do dual stack on 1 connection. 2 connections is twice the licenses to the vendor, and it's twice the resource consumption on the air. So in the mobile market, dual stack is really hurting the operators. That's why T-Mobile pushed so hard to have the 464 XLAT into the Android operating system. Once they get to IPv6 only, and T-Mobile is already IPv6 only, that's why I asked. IPv4 sites will be accessible only over NAT. NAT is expensive. Large-scale NAT is really expensive. And guess what? Facebook is on IPv6. Netflix is on IPv6. YouTube is on IPv6. Google, yeah. Who cares about the remaining 10% of the traffic?
Well, they all go through Akamai anyway, and Akamai is v6 enabled, so, yeah. I mean...
You know, when you can complain on Facebook that your e-commerce site is down, it's your bank's problem. It's not your service provider's problem anymore.
Yeah. And, I mean, for example, my blog is IPv6 enabled, but not because my provider's IPv6, my CDN is. Yeah. Right? So, I still don't care about I still don't care about IPv4. IPv6 because I can put, you know, if I've got an IPv4 enabled web server, I put a CDN in front of it, which is free, right? Yeah. And it's IPv6, and I don't care.
Yeah, I think the interesting thing will be if you're in the space where you actually are developing mobile apps or you're doing things in that area, you need to pay more attention to v6 simply because the handset that you want to talk to, that end user you want to talk to, you want to have that one-to-one relationship. You don't want to go through multiple stages of NAT. You probably want to do something native v6. I think that would be reasonable to think of at that point. Is to, not necessarily Internet of Things, but if you're actually, you know, a mobile provider of application suites, right?
Internet of Things is actually a key driver. You're talking about just a vast number of endpoints. So if you start having Hughes and door locks and HVAC systems and, you know, air conditioning and, you know, all those sorts of things are suddenly connected to the internet, even with NAT, you're not going to be able to cope because you're only going to have 30,000 concurrent TCP sessions on a NAT onto a single IP. And, you know, you're talking about a corporate office that's going to have way more than 30,000 endpoints, security systems, cameras, you know, all that sort of stuff. And then the explosion in endpoint count might be a driver in the public network, but just to come back around to the enterprise, I still don't care. So, whether my desktop has IPv6 or not?
Yeah, that's my experience. I work for enterprise, right? So I can see that in my thermostat at home connect to the internet that I need the IPv6 if that wanting our IPv4 address. But my enterprise, given the owners /16, we never, as you mentioned, never run out of IP address. Public facing, yeah, we have a DMC, we have multiple DMC, but never run out of IP address.
You'll eventually have to implement IPv6 eventually because there'll be users only able to get IPv6, right? But you can just use a CDN in front of it and not have to, or use a load balancer with an IPv6 to an IPv4 NAT.
It sounds like one of the things we're saying here is that IPv4 support isn't going away, so no one's got any, if they've got enough addresses, why would they bother to change?
So what about the interesting use cases? So there are enterprises that are large enough that if they aren't running public address space internally, there are a few that do that. But there are companies that are large enough they've run out of RFC 1918 space internally. And that's a structural problem. That's a different structural problem.
That becomes a priority. Like, what's your most important thing? You know, if you're a network engineer, what's on the top of your list? Redoing the DMZ, implementing SDN in the data center, SDN WAN, you know, replacing your firewalls from static firewalls to app firewalls. Right. I've run out of IPv4 addresses, I got to do something. Okay, this goes to the top, right? That's it. But you know, that is a corner case. That is not a mainstream condition. Okay, if that makes sense.
Yeah. So what about now? We are talking about internet-facing IPv4, IPv6. Is there any use case that we run IPv6 inside the campus network or even inside the data center? Is there any advantage for running IPv6 versus right now running IPv4?
Yeah. So there was this one use case, one of the American construction companies. They were using 1918 internally. And the problem is that they were running a bit out of the address space. Yeah. So when they deployed a new site, a new project, they never knew how much address space to allocate to that project. And as that project grows, you know, you run out of address space, so you give it another subnet, another subnet, another subnet. You have a total mess on site. Right now, with IPv6, they can allocate /56 or whatever it is, or even /48 to every single new thingy. And it can be 3 people forever, or it can be a huge construction in 2 years. They always have enough address space. They got a /32 or maybe even more address space. So who cares?
It's a good use case, but again, it's a corner condition. Yeah, sure. You know, that's not a mainstream entire market shift.
Acquisitions. Just imagine if you would have IPv6 and you would have to merge to IPv6 networks versus merging to RFC 1918 networks.
Well, Ed, to speak to a point that I've heard you make in a presentation, you're already running IPv6 very likely. Windows operating systems are going to use IPv6 if it's available out of the gate.
Yeah, I think one of the other arguments around, and so my argument around this isn't necessarily that you should be forcefully adopting v6, but my argument is that you can't ignore it, that you have to be educated about it. And the reason why is because if you're running an environment where you have to have PCI compliance or any other audit compliance, and you're saying my default policy is not to run it, or I choose to ignore it, which I consider blinders, there's no way you can check off the box that says you're in compliance, because if you were running around running some other networking protocol that was connecting a bunch of stuff or giving you exploits. And so my argument is you at least need to get the education about understanding it, controlling it, putting the right procedures and policies in place. And if you are going to turn it off, you better have something that can go out and inspect it and tell you that it's actually off.
And I would echo that, and I would add on to that. Make sure that the applications that you have running in the background aren't actually using v6.
Yeah.
Because I mean we're a very large consulting shop, and we're a very big Active Directory customer, and we use direct access, and that's all native v6 out the gate. Because I actually looked at that from a security perspective and said, can I turn this off? And I looked at it and went, oh, DA is running v6 natively. I can't do it.
Yeah, every time you have 2 Windows servers on the same subnet, they will run IPv6. Link local addresses, they don't care. It's IPv6.
All right, I think we're going to call this discussion here. There's obviously a lot of interesting depth in this particular topic. And if you'd like to learn a little bit more, you can head over to techfieldday.com. We have hours and hours of recorded networking field day videos that you can watch, understand these topics in more depth, because we do have a networking field day coming up this August, and it's a great opportunity to learn more about what's going on in networking and see where things are going. So definitely stay tuned to that, and look for more of our videos coming out of Tech Field Day Extra at Interop and other Tech Field Day events.